Hey, welcome to CAD That Works. Today I'm going to show you how to design a fidget spinner from scratch using Onshape, and we'll go all the way through to 3D printing and testing it. But this isn't just for fun. I'm going to show you how to get the right tolerances for real-world fit and function. Okay, so let's jump right into it. Let's go ahead and open up Onshape. We'll go to Create, Document, Fidget Spinner _ 1, create public document. And we're going to create a standard 3-lobed fidget spinner design. So let's go ahead and go to our top plane by left clicking right up here. We don't have to, but just kind of orients it, makes it a little nicer. So typical fidget spinner, you have a bearing in the center and 3 equally spaced around it. So let's go ahead and sketch that out. Select that top plane. Let's draw our first center circle for the bearing. Now, dimensions don't really matter right now because we can always change that here in a minute. Okay, let's draw our 3-lobe design. So we need that to be equidistant. So we're going to go ahead and select line and then construction. So 360 divided by 3 is going to be 120. So we're just going to draw that out, draw that construction line out. Hit L to close that, hit L again, open it back up. We're actually going to do that there too. And there we go. Now we're going to hit D to dimension it to make that 120 degrees apart from each other. 120. 120. Okay, one thing that we did not do yet is we need to adjust our workspace units. So it's in inches right now. The bearings are, they're metric bearings. So we'll just do it in millimeters. And that's what Prusa is going to want as well. So let's just change that right now. Workspace units, change it to millimeters, green check. There we go. Okay, let's go back to our sketch. Right click, edit. Okay, let's select that line. Let's make that 45. And then we're going to make each of these construction lines equal. So each circle is going to be equally spaced. We'll hit E, select that. Select it again, select the other one. And there we go. So then we're going to do our outer lobes of our body. Draw some circles. We hit C, and then we just left click there on the center. You can see it highlights that, snaps to it. Okay. Then we're going to make all those equal. So we're going to hit the letter E again for equal. It's going to constrain all those circles to be equal. So we left click, select the next one, select it again, and select that one. Now they are all the same size. So to create the body of this fidget spinner, we're going to go to 3-point arc. I'm going to select that outer circle there, select it up here. I'm going to kind of just adjust that to about where I think looks pretty good. Do the same thing down there, left click. Make sure it's highlighted when you left click. You do want it constrained to that circle. Oh, there we go. Now we're going to make those lines tangent to that outer body. So let's go ahead and hit tangent. You can hit the letter T or just go up here. Left click that line, left click the circle. You can see it makes it perfectly tangent to each circle. You do all those lines. All right, so now one thing we need to do, we do need to dimension our inner circle for our bearings. So, these fidget spinners typically use rollerblade bearings, which are 608 bearings. And a good source of information, if you're not familiar, is McMaster-Carr. They have pretty much any hardware you could ever imagine. But anyway, I look up 608 bearings, and it gives me all the dimensions, and it gives me the tolerances. So I can see that the outer diameter of that bearing is 22 millimeters. Plus 0 minus 0.009 millimeters. That's pretty tight. So that means that bearing can be no bigger, and will be no bigger, than 22 millimeters, but it could be as small as 21.991 millimeters. Because we want to be able to press this bearing into this hole without using a glue. We want that pretty tight. Now, we were doing a true interference fit with a more precision machine. The diameter here would be right at or slightly smaller than the largest diameter of the bearing. But because it's 3D printing and that circle, I know it's going to be a little off, I'm actually going to make that 22.1 millimeters. And I think that'll be just fine. So let's go ahead and hit the letter D for dimension. Select that. Do 22. Okay. So when I do that, I do get kind of a scale for this whole thing. So I do want to kind of decrease the overall size. So let's make that 40. Actually, let's do 35 millimeters. Okay. So there we go. So now we have a sketch, but we do need to trim it. Okay, so there we go. We've trimmed everything, and we are ready to go ahead and accept the sketch. Oh, it says it's not fully defined, which means we forgot to dimension something, which what we forgot to define was the diameter or the radius right now of this. Let's make that, let's just do 15. We forgot the radius of those. So let's do 60. Okay, so then we're going to hit the equal command, make all those the same. Do the same for this radii. Okay. Hit the green check. Now we've got start beginnings of our fidget spinner. Go ahead and hit extrude. Sketch. Now if we go back here, we can see that that bearing is no more than 7 millimeters tall. We don't quite care about how tight it's going to be, but we're just going to go ahead and make it 7. Okay, so then there we go. We've got the basic body of our fidget spinner. Now, the next thing we do, we need to make the holes for our bearings are going to go along the circumference at each lobe. So we're going to hit sketch, select this plane. Now we could have done that in the first sketch, but this allows me to show you how to do a circular pattern. So I'm going to create a circle, and I do want it, you see it snaps right to the center of that lobe there. Okay, so left click, draw that out, left click again, hit D for dimension, 22.1, I want that the same. Okay, green check, hit extrude again. Now this time we're going to go to remove because we are removing material. We're making a hole. So hit that select that second sketch. You can leave it as blind, but we're going to do through all. We'll take it through everything you've just modeled. Okay, so there we go. We've got that hole. Okay, and now I do want to add a little chamfer to both sides. That's way too big, so let's make that 0.5 millimeters. That will help install the bearings and just makes it look a little better, in my opinion. So hit green check. Now we're going to do a circular pattern, which will basically automatically create these holes around this center. But we do need to create a center line for the pattern to go against. So let's hit sketch, and you can select the right plane or the front plane, because both of those do go through the center. So let's just do the right plane. We'll hit line, make it a construction line, select that little circle right there, a little dot. Now you can see I know I'm in the center when it highlights yellow and blue. That snaps to the center. That's all I need. I don't need to dimension that. I just need the line. Green check. Circular pattern is right here. Circular pattern. I select that. And we are not doing a part pattern. That would be like if we were patterning the fidget spinner body itself. We are doing a feature pattern. A feature is going to be an extrude, a chamfer, things like that. Let's hit our second sketch, our extrude, and our chamfer. Our axis of pattern will be that line we just sketched. Okay, now you can see it says 360, we're going to do 4 of them. We don't want that. We want 3 of them. Right? There we go. And we'll equally space 3 of those. The hole, the chamfer, and everything perfectly like that. Green check. Okay, now to kind of make this look a little nicer, we're going to add a chamfer on the edges. Let's make that 2. There we go, it looks pretty good. Now, we do need another chamfer here on that center bearing. Make that 0.5 again. Now we can leave it like this, but let's make this look a little cooler. So let's go ahead and add some flair to it. I'm going to sketch. I'm going to select that front plane. Go ahead and change the top so it's centered. I'm just going to create some cutouts centered around here. We're going to do the same circular pattern type thing. So we're going to do a line, construction. We're going to bring it out. Okay, and we're going to dimension from that line, that plane to there. Let's make that 30 degrees, and from there to there, make that 60. And then we're going to do a line, a circle. Actually, we could do an arc. So let's do an arc. Let's do a center point arc. So that means we just select the center. Select that construction line, left click, bring it over, do the same thing. Center again. Okay. We're going to dimension that. Let's do 14. Let's dimension that outer radius. Let's do 22. Okay, now we need to draw a line to close that sketch. So we're just going to select right there, bring it up to there. Same thing over here. Click. Okay, now we've got our sketch. We're going to go up to extrude, select sketch number 4, change it to remove. And this time to show you something a little different, go up to nixed. That's just going to take it up to the nixed surface, which is that surface. It's another way to do it. Okay, green check. Let's do another chamfer. Make that 2. Looks okay. Let's do 1.5 actually. All right, 1.5. Okay. So we've got that cut out. Now we want 2 more of these to make sure the whole thing's balanced. So we're going to do the same circular pattern. Feature pattern. Sketch 4, extrude, chamfer, axis of pattern. And that was that sketch. You see it's hidden now, but it's still there. So it's actually invisible. Make that visible again. So let's select that. Okay, now we don't want 4, although we could do 4. I don't really like how that looks so let's just do 3. All right. There we go. Fidget spinner design is done. Let's go ahead and export that. Go up to part, right click, export. Rename that Fidget spinner V1. Millimeter, fine. We're going to download. Okay, so it is exported. Now we're going to jump right over to Prusa here in a second. Okay, so here we are in Prusa. We're going to hit Control I, import. Fidget spinner V1. It's already on the plating surface, came in perfectly. Now we're going to do PLA for this one because it's not really a superstructural part. We can do, I think 15% infill will be fine. The only thing I'm really going to change is my print settings. I'm going to make that, well, it's already at 4 perimeters because I am pressing those bearings in there. I want that wall thickness to be a bit thicker than normal so that the bearings don't crack it or anything. And if I need to sand it to get those bearings to fit, I can. So, okay, so that's ready. We're going to hit slice. Okay, it's going to take about an hour and 16 minutes. Not too bad. Export. And there we go. All right, now it is ready to Put that file on an SD card, take it to the Prusa printer, and hit go, which I will show some footage here in a minute. Okay, the print's all done. Came out okay. Surface finish looks pretty good. There is a little bit of stringing in there. I could adjust some parameters on the slicer as far as temperature and whatnot, but I don't think it's really going to affect anything. I'll just take a lighter or some real fine sandpaper and kind of get rid of those strings. But yeah, looks good. Next step, we'll go ahead and try the bearings out and see if they fit. Okay, so the fidget spinner is all complete now. I went ahead and installed the bearings off camera with my vise. I did have to sand down the holes a little bit. I didn't really take too much material away. There was just a couple little blobs, tiny little things. I wanted just to smooth them up, just to make those bearings able to be installed a little easier. They did go in pretty easy, but they are definitely snug. They are definitely not coming out. And look at that, it spins great. And it was designed with function in mind, and that's what CAD that works is all about. So if you like this build and want more real-world CAD projects that actually work, hit like, subscribe, and drop a comment with what you'd like to see next. See you in the next one.